Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to try and answer the question, did this variable actually earn its place in the regression? In the previous video, we talked about R squared and what it measures, especially how much variation in the Y is explained by the model. But there is a catch. R squared, the way that it is constructed, it has a mechanical problem, as we will call. Well, and that's why, on top of the R squared, we also need another element, which is called the adjusted R squared. Okay. So what is this mechanical issue with R squared? The idea is, if you add more regressors to a model, R square will never decrease, even if this new variable is like completely irrelevant to your model. Why? Because the regression can always feed the data at least as well as when you give it more flexibility. Okay, so in a sense, R square rewards complexity even when it's not deserved, meaning when you're adding a variable that is completely irrelevant. Okay, so does not decrease when irrelevant. Variables are added. In fact, it increases. Why is this a problem? Well, if we only looked at the R square, then the best model would be the one with the most variables. But that's not good econometrics, as we have seen, because what we want models that explain variation. And we want that without overfitting, because we want a best model that describes the relationships that we are trying to investigate. And this is where adjusted R square comes into the picture and tries to fix this mechanical problem introduced by the R square. So adjusted R square is trying to answer a more difficult question, so to speak, and that is, did this new variable actually improve the model enough to justify using up a degree of freedom? Okay, so in a sense, the adjusted R square is penalizing you for adding regressors that don't pull their weight or they don't do their job in this regression. The formula for the adjusted R square, and in order for not writing adjusted all times, I'm just going to add a bar on top of the R squared, and this will be the adjusted R square. We can write it as follows. 1 minus the residual sum of squares divided by n minus k minus 1, and then total sum of squares divided by n minus 1. Okay. This formula, what it's doing is it scales unexplained variation by its degrees of freedom. So n in here would be the number of observations, k is the number of variables in your regression, and 1, this is for the constant. And the other part that is scaled is also here, the total sum of squares by the degrees of freedom of the total variation. So when I said earlier that adjusted R squared is penalizing you, in a sense, for adding the regressors that are not doing their job in the regression, these numbers in here are the ones that are translating mathematically that penalization. Now, keep in mind, you don't need to memorize this. You just need to understand what it's correcting for. Most of the times, any exams, they don't really require you to remember all of these formulas, especially for the adjusted R-square. However, you need to know why do we need it, what it's correcting for, and why does it give you a better overview of what you want to know compared to the R-square. Okay? Now, based on this formula, unlike the R-squared, the adjusted R-squared can actually go down in value. Okay? When you are adding a regressor. And that drop is informative because it means the X variable that you just added is not giving me any further information. This variable is only adding noise, not a signal of what is happening between the variables. Usually the R-square and adjusted R-square, be that in theta or in R, are right next to each other. And this is because they answer closely related, although not identical questions. And sometimes it's good to have both of them side by side so that you can have an idea of what is happening with your model. Now, just the same way that we had things that R-square was not telling us, there are also things that the adjusted R-square does not tell us. And those will include the same as R-square, does not tell us that the model is the model is causal, so does not tell us causality. It's not telling us whether assumptions hold. And whether coefficients are unbiased. So in a sense, the R-square is just a model fit statistic. And basically not a truth detector. Yeah. Think of it this way. If R-square is asking you, how much did we explain? The adjusted R-square is asking, was it worth it? And that's the difference between the two of them. In the next video, we'll compare the R-square and adjusted R-square directly and see like how this naturally leads to the idea of like testing whether groups of variables matter jointly. So stay tuned and I'll see you in the next video.